NC connectors typically have a built-in bushing or strain relief that secures the cable to the connector. This bushing helps to prevent the cable from being pulled out of the connector and provides strain relief to protect the connection. NC connectors, short for multi-contact connectors, are commonly used in electrical and electronic applications due to their rugged construction, high current carrying capacity, and ability to withstand harsh environmental conditions. They are often used in industrial, automotive, and telecommunications applications. When selecting an NC connector, several factors should be considered to ensure it meets the specific requirements of the application. Firstly, the current and voltage ratings of the connector must be adequate for the electrical load it will be carrying. Secondly, the environmental conditions in which the connector will be used should be taken into account. Thirdly, the size and type of cable being used must be compatible with the connector. Fourthly, the ease of installation and maintenance should be considered. Fifthly, the cost of the connector should be factored into the overall project budget. In terms of current and voltage ratings, it is crucial to select a connector that can safely handle the maximum current and voltage levels expected in the circuit. Exceeding the connector's ratings can lead to overheating, insulation breakdown, and even electrical fires. The voltage rating indicates the maximum voltage that the connector can withstand without experiencing dielectric breakdown. The current rating specifies the maximum continuous current that the connector can carry without overheating beyond its safe operating temperature. Environmental conditions play a significant role in connector selection, especially in harsh environments. Factors such as temperature, humidity, vibration, and exposure to chemicals or corrosive substances can affect the connector's performance and lifespan. Connectors designed for harsh environments typically feature robust housings, sealed interfaces, and corrosion-resistant materials to protect against these elements. The size and type of cable being used must be compatible with the connector to ensure secure and reliable connection. The connector's wire gauge range should match the gauge of the cable conductors. The cable's insulation type should also be compatible with the connector's insulation displacement or crimping mechanism. Using the wrong size or type of cable can result in loose connections, increased resistance, and potential failures. Ease of installation and maintenance is an important consideration, particularly in applications where frequent connections and disconnections are required. Connectors with simple and intuitive designs can save time and effort during installation and maintenance. Features such as color-coded markings, quick-release mechanisms, and tool-less assembly can enhance usability. The cost of the connector should be factored into the overall project budget. While it is tempting to choose the cheapest option, it is important to consider the long-term costs associated with connector failures, downtime, and maintenance. Investing in high-quality connectors from reputable manufacturers can provide better reliability, performance, and longevity. When working with electrical connectors, it is essential to follow safety precautions to prevent electric shock and other hazards. Always disconnect the power supply before making or breaking any connections. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. Inspect connectors for damage or corrosion before use. Do not use connectors that are cracked, broken, or show signs of overheating. Ensure that connectors are properly tightened and secured to prevent loose connections. Loose connections can cause arcing, overheating, and even electrical fires. Regularly inspect and maintain connectors to ensure they are in good working condition. Clean connectors with a suitable solvent to remove dirt, dust, and corrosion. Replace connectors that are damaged or worn out. NC connectors are available in a wide variety of types, sizes, and configurations to suit different applications. Some common types of NC connectors include circular connectors, rectangular connectors, and D-sub connectors. Circular connectors are often used in harsh environments due to their robust construction and sealed interfaces. Rectangular connectors are commonly used for connecting multiple wires or cables in a compact space. D-sub connectors are widely used for computer and data communication applications. The choice of connector type depends on the specific requirements of the application, such as the number of conductors, the current and voltage ratings, the environmental conditions, and the space constraints. In addition to the basic types of MC connectors, there are also many specialized connectors available for specific applications. These connectors may feature unique designs, materials, or functionalities to meet the specific needs of the application. For example, there are connectors designed for high-temperature environments, connectors designed for underwater applications, and connectors designed for explosive atmospheres. When selecting a specialized connector, it is important to carefully consider the requirements of the application and choose a connector that is specifically designed for that purpose. MC connectors are typically made from a variety of materials, including metals, plastics, and ceramics. The choice of materials depends on the specific requirements of the application, such as the current and voltage ratings, the environmental conditions, and the cost. Metals are often used for the connector's contacts and housings due to their high conductivity and strength. Plastics are often used for the connector's insulators and housings due to their low cost and good electrical properties. Ceramics are often used for high-temperature applications due to their excellent thermal stability. The materials used in MC connectors must be compatible with each other to prevent corrosion and other problems. For example, it is important to avoid using dissimilar metals that can cause galvanic corrosion. Galvanic corrosion is an electrochemical process that occurs when two different metals are in contact in the presence of an electrolyte, such as water or salt. The more active metal corrodes, while the less active metal is protected. To prevent galvanic corrosion, it is important to choose compatible metals or to use a protective coating on one of the metals. MC connectors are typically manufactured using a variety of processes, including machining, molding, and stamping. Machining is used to create precise parts from metal or plastic. Molding is used to create complex shapes from plastic or rubber. Stamping is used to create thin, flat parts from metal. The manufacturing process used depends on the specific design and materials of the connector. Quality control is an important aspect of MC connector manufacturing. Connectors are typically tested to ensure they meet the required specifications for electrical performance, mechanical strength, and environmental resistance. Testing may include visual inspection, dimensional measurements, electrical testing, and environmental testing. Connectors that fail to meet the required specifications are rejected. MC connectors are an essential component in many electrical and electronic systems. They provide a reliable and convenient way to connect wires and cables. When selecting and using MC connectors, it is important to consider the specific requirements of the application and to follow safety precautions to prevent electric shock and other hazards. With proper selection, installation, and maintenance, MC connectors can provide years of reliable service. Electrical connections are crucial for the functionality of any electrical system. A faulty electrical connection can lead to a variety of problems, including power outages, equipment malfunctions, and even electrical fires. Therefore, it is essential to ensure that all electrical connections are made properly and are well maintained. One of the most common causes of electrical connection failures is corrosion. Corrosion is the gradual destruction of a material due to chemical reactions with its environment. Electrical connections are particularly susceptible to corrosion because they are often exposed to moisture, humidity, and other corrosive substances. Corrosion can increase the resistance of an electrical connection, which can lead to overheating and eventual failure. Another common cause of electrical connection failures is vibration. Vibration can loosen electrical connections over time, which can lead to intermittent contact and eventual failure. Vibration is particularly problematic in applications where electrical equipment is subjected to high levels of vibration, such as in vehicles or industrial machinery. Overheating is another common cause of electrical connection failures. Overheating can occur when an electrical connection is carrying more current than it is designed for. This can cause the connection to overheat, which can damage the insulation and eventually lead to failure. Overheating is particularly problematic in applications where electrical equipment is operating at high loads or in high-temperature environments. To prevent electrical connection failures, it is important to use high-quality connectors and terminals. High-quality connectors and terminals are made from durable materials and are designed to provide a reliable electrical connection. It is also important to properly install connectors and terminals. Improperly installed connectors and terminals can lead to loose connections, which can increase the risk of failure. Regular inspection and maintenance of electrical connections is also essential for preventing failures. Electrical connections should be inspected regularly for signs of corrosion, vibration, and overheating. Any damaged or corroded connectors or terminals should be replaced immediately. In addition to preventing failures, proper electrical connections can also improve the efficiency of electrical systems. A well-made electrical connection will have low resistance, which will minimize energy loss. This can lead to significant energy savings over time. Electrical safety is another important consideration when making electrical connections. It is important to always disconnect the power supply before making any electrical connections. This will prevent the risk of electric shock. It is also important to use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. Following these safety precautions will help to ensure that electrical connections are made safely and properly. In summary, electrical connections are a critical component of any electrical system. Proper electrical connections are essential for ensuring the reliability, efficiency, and safety of electrical systems. By using high-quality connectors and terminals, properly installing them, and regularly inspecting and maintaining them, it is possible to prevent electrical connection failures and improve the performance of electrical systems. The National Electrical Code, or NEC, provides guidelines for safe electrical installations. When making electrical connections, it's crucial to adhere to NEC standards. The NEC covers aspects such as conductor sizing, overcurrent protection, and grounding. For example, NEC Table 310.16 provides ampacity ratings for conductors based on their size and insulation type. It's vital to select conductors with sufficient ampacity to handle the anticipated current load to prevent overheating. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. The NEC specifies the appropriate size of overcurrent protection devices based on the ampacity of the conductors they are protecting. Proper grounding is essential for electrical safety. Grounding provides a low impedance path for fault current to return to the source, which helps to trip overcurrent protection devices and prevent electric shock. The NEC specifies the requirements for grounding electrodes, grounding conductors, and bonding. In addition to the NEC, local electrical codes and regulations may also apply. It's important to be familiar with and comply with all applicable codes and regulations when making electrical installations. Failure to comply with electrical codes can result in fines, penalties, and even legal action. Therefore, it's always advisable to consult with a qualified electrician to ensure that electrical installations are performed safely and in accordance with all applicable codes and regulations. They can provide guidance on selecting the appropriate materials, making proper connections, and ensuring that the installation meets all safety requirements. A qualified electrician can also perform inspections and testing to verify the safety and integrity of electrical installations. The importance of proper wiring cannot be overstated. Poor wiring practices can lead to a range of problems, from minor inconveniences to serious hazards. Some of the common consequences of poor wiring include voltage drops, which can cause lights to dim and appliances to malfunction; overheating, which can damage insulation and create a fire hazard; electrical shocks, which can cause serious injury or death; equipment damage, which can result in costly repairs or replacements. To avoid these problems, it's essential to follow proper wiring practices. This includes using the correct wire size for the intended application, making secure connections, and protecting wires from damage. It's also important to properly ground all electrical circuits to prevent electrical shocks. When working with electrical wiring, always disconnect the power supply before starting any work. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. If you're not comfortable working with electrical wiring, it's best to hire a qualified electrician. They have the knowledge and experience to perform electrical work safely and correctly. Electrical wiring is a complex and potentially dangerous task. By following proper wiring practices and taking the necessary safety precautions, it's possible to avoid many of the problems associated with poor wiring. Regular inspections of electrical wiring can help to identify and correct any potential problems before they become serious. Look for signs of damage, such as frayed wires, cracked insulation, or loose connections. If you notice any problems, have them repaired by a qualified electrician as soon as possible.